Hi everyone, my name is Paul. Today we'll be looking at the practical example of how we can solve linear programming problems using Excel. In our previous video, we have gone through the key components of linear programming, which have been explained and given examples, series of examples, and today we're going to look at the real world problems. I have a problem here. Okay. We have a real world problem. This is from Mr. Pedro Fernandes. He's a businessman. He lives in Portugal. He has a factory, but he has this problem. I want us all to read it together. Mr. Pedro Fernandes owns a paint factory in Faro, Algarve in Portugal. He produces two types of paint: water-based paint and aluminium paint. Producing 1 liter of water-based paint requires 0.1 kilogram of certain pigment, and 1 liter of aluminium paint requires 0.2 kilogram of the same pigment. factory has 20 kilograms of this pigment available per week. Producing 1 liter of water-based paints required 0.05 hours of mixing time, and 1 liter of aluminium paint requires 0.1 hours of mixing time. Are we together? Okay, that's perfect. So, factory has 10 hours of mixing time available per week. Due to market demand, the factory can sell at most 8 liters of aluminium paint per week. Profit per liters of water-based paint is €5, and the profit per liters of aluminium-based paint is €8. Now, what is the problem? The factory owner, which is Mr. Fernandez, okay, want to maximize his profit. So now we have I have prepared some write-up solution for easy explanation. So now we have a solution being solved. Now remember that we have the key component of linear programming. We are solving this problem using linear programming, and we're going to be using the powerful tools, Excel powerful tools, to solve this problem. Now we have, first and foremost, you must express your problem mathematically. You must firstly state out the 3 components that we need to solve this problem. The first component is called decision variable, and the second component is also called objective function, and the third component is the constraint. Now, what is decision variable? In our past lesson and videos, we have explained what decision variable is. Decision variables are variables that a manager or individual or owner of the business can manipulate or change in order to maximize his profit. So these are called variables that is needed in the problems. Okay, now we are able to mathematically present the 2 problems using x and y as the variables. So we say let x be the number of liters of water-based paint produced per week, and let y be the numbers of liters of aluminum paste produced per week. This expression will be transferred to Excel very soon, but we need to understand what we're going to do when we have our Excel tools. Okay, now we look at the objective variables. Now remember that the objective variables is the main optimization problem that we need to look into, or that the owner of the factory, Mr. Fernandez, want to achieve. Okay, now in this concept, he want to achieve profit. He want to maximize his profit. So therefore we assume that the profit per liter of water-based paint, as been stated in the problem, is €5, and the profit per liter of aluminium paint, as stated in the problem, is €8. So the factory owner want to maximize the profit. So that is our objective function. Okay, so therefore we express our objective function as z is equals to 5x plus 8y. Remember that we are looking at this problem using linear programming. If you recall from linear equation, okay, from linear equation, we say z, we said y is equals to ax plus by. Remember, we have this as our linear equation, okay? And the coefficient of x is a. So if you look at the problem as being expressed mathematically, the coefficient of x here is 5. So a is equals to 5. Now, if you look at also the variable y, which represents, you understand, the aluminium paint, its coefficient of y is b, which is represented by numeric value 8. Okay, I think we getting it gradually. Now, having understanding how to express our optimization problem and how to look into it by our objective function, then we can now begin to look on the problems that we need to solve, which is the constraint. Now, in this problem, we need to introduce some constraint based on production process and available resources. Remember, one of the examples that we have explained in the previous video is constraint using resources as availability. And when we look at our resource availability, we have to look at what materials that is available for us to make a certain production. So in this term, we have a pigment constraint. Now, remember in the question we said producing 1 liter of water-based paint requires 0.1 kilogram of certain pigment, and 1 liter of aluminium paint requires 0.2 kilogram of the same pigment. So the factory has 20 kilogram of pigment available per week. So this simply implies that the constraint inequalities is given as 0.1 hex, which is the coefficient of x is 0.1 plus 0.2y is less than equals to 20. This statement simply means that you cannot produce what you have. You cannot produce you cannot have a production than or more than what you have. You can only produce within what you have. So the factory, okay, now having understand what statement means, okay, again I'm trying to let you understand that if you have a materials of 20 pieces, you can only produce whatever you want to produce within what materials you have. You cannot produce beyond what you have, otherwise it's gonna be a technical problem. Okay, so now we understand that is a pigment constraint, because the pigment constraint here is 20 kilogram of pigment is available for production per week. So it has been simply stated by 0.1x plus 0.2y is less than equals to 20. You cannot produce more than 20. Okay, you can produce less but cannot produce more than 20 because the materials available is just 20 kilogram. Okay, now also remember that in production we also have a constraint called time constraint. Okay, so this is a constraint also we have to look into as part of the question. Now this is mixing time constraint. Now the production of 1 liter of water-based paint requires 0.05 hours of mixing time, and 1 liter of aluminium paint requires 0.1 hours of mix time. So the factory has only 10 hours to make all this production available. So it is stated inequality by saying 0.05x plus 0.1y is also less than equals to 10. So you can only produce this quantity of paints, either it is a water-based paint and or aluminium paint. You're only given 10 hours to do the production. Okay, now that is the second constraint in the question. Now let's look at the other constraint. Other constraint in this question is the demand constraint for aluminium paint. Now remember that there was a demand for aluminium paint, which is the factory can sell at most 80 liters of aluminium paints per week. So the particular demand for aluminium paint is 80 per week. So it is also expressed by inequality, saying that y, because y represents from our decision variable, if you remember, our y represents what? Aluminium paint. So we said y is also less than equals to 80. They only produce 10 liters of aluminium paint per week. You understand? So because the factory can sell at most, it means not beyond, is at most 80 liters of aluminium paint per week. So it's expressed by y is less than equals to 80. Now remember, in this kind of problem you must not get a negative value. So it is very important to make an expression of non-negative constraint. It is essentially important. You must have that in one part of your mind when you are solving a linear problem that has to do with production. Okay, you cannot have a negative value. So therefore we say the number of liters produced cannot be negative. So mathematically we express that x is greater than equals to y. And in mathematics, when you bring y, when you bring y, move beyond or to cross the equal sign, it becomes negative. So this is y and this is gonna be x. So then for y, we cross the equal sign and become minus x. Okay, that will be greater equals to 0. So x is greater equals to y because it must not be negative. Okay, and we have the expression that says x minus y is greater than equals to 0. So every value of this, okay, is greater than 0. It could be 1, okay, but it cannot be negative, cannot be minus. Okay, so we have this expression as non-negative constraint. Okay, so now let's move into problem using Excel. Now I have this template already made for us in order to easy make the problem easy for us to solve. Okay, now I have explained that y and x and y is representing the water-based paints and aluminium paints. Okay, now it is important for us to understand our decision variables. So here we have this domain variable numbers. So here I create a box. Okay, you have to create a box because this is the numbers you are actually looking for. How many X that can be produced, how many water-based paint that needed to be produced to maximize profit, and how many aluminum paint that needed to be produced also maximize profit, because the main objective is to maximize profit. Okay? So that is our objective function. Okay, let's go. So now we have decision variables here. Now remember that the profit that is being stated in the problem, liters of water-based paint is $5. Okay, and also recall that the profit that has been stated for aluminum-based paint is 8. Remember the equation that says that 5x plus 8y, okay, is what? Is less than equals to what? Z. Okay, that is the our objective function. So now we're going to use a formula here, mathematical formula from Excel called sum products. So we say is equals to sum products of these variables. You can you can drag the two variables, the expected profit, which is the profit made by water-based paint and the profit made by aluminum-based paint. Okay, so we have it. Now it is blank because there is no domain, there is no numeric value. Yeah, so for us to make it easy, let's just put 1 and 1 here. So you have it 5. So if you multiply this by this plus this by this using the mathematical expression by linear equation, you have 13. So that's one thing about Excel tools that is so interesting. Now remember that we already had our constraint stated out from the expression. Okay, first constraint, if you remember, is the pigment. Okay, so we can just copy from here, then come to our Excel, put it here. Okay, now we have to proceed. Okay, now we want to put in all the variables, all the constraints from our constraint component. So we have the pigment constraint. It says that producing 1 liter of water-based paint requires 0.1 kilogram of certain pigment, and 1 liter of aluminum paint requires 0.2 kilogram of the same pigment. The factory has 20 kilogram. Blah 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 blah. So we have 0.1x plus 0.2y is less than equals to 20. Okay. So now we put this into our Excel sheet. This is gonna be 0.1. This is gonna be 0.2. So yeah. So now the left hand side is the mathematical expression. So we say it's equals to sum products. Okay. The domain value cells. Okay. Domain value numbers. And the constraints. Okay, so we have this. Now because we're going to drag this down, so so we can put reference the cell, this cell not to change. In case when you are referring or referencing the cell from this table, it remains the same. Otherwise, sometimes you can have cells looking into the corresponding cells as a reference. But when you reference a cell, it's easier for you to get the right value. So this is done. Then we can look at the mixed time constraint also. We have the mixed time constraint. Here is 0.05 plus 0.1 is less than equals to 10. It means that the hours that is need to produce water-based paint and aluminium paint is 0.05 and 0.1. Okay, it is less than equals to 10. So we put it in our Excel sheet. 0.05. Okay. Sorry. Need to repeat the formula is equals to this is sorry. Okay. This is equals to some product. Okay. Like these common these ones is inside. Okay, so you put your reference absolute reference. Okay, yeah, just as I explained earlier. So then sorry, I need to do something here. Go again. This cell, this cell. Okay, let's make sure we reference this one. You can use a shortcut from your keyboard, F4. Yeah, that's done. So then this one is 0.05 plus 0.1. Okay, 0.05 0.1. Okay, then remember the sign here is less than equals to here also is less than equals to, and this is 20 kilogram rare, sorry, and this is you just drag this down, then you get the same value, then and this is 10. Okay, good. So what other constraint do we have from our solution? We have demand constraint for aluminum paint. Yes, so due to the market demand, where the factory can sell at most 10 liters of aluminum paint a week at most. So this is less than equals to 80. So put our Excel, put it here. A little bit smaller, so because it's only talking about aluminum paint, so you just ignore the water-based paint. Okay, so less than equals to 80. So here from the equation is y is less than equals to 80. Okay, so the coefficient of y here is 1. Okay, the coefficient of y here is what? 1. So ignore this, you put y here because this is y axis. You put y1 here, then you drag it down. Okay, and this is less than equals to and this is 80. Okay, then what do we have also? Let's go Now we have non-negative constraint. Remember, you must include non-negative constraint into your constraint table. It's very important. Otherwise, the problem may not be properly solved. Okay. So we have this, reduce the size. Okay. Then now from here, we have the mathematical expression that I've made here. Say x is greater than equals to y. So if you bring x to cause this equal sign, you have x minus y is greater than equals to 0. So whatever the variable is, okay, it cannot be negative. It's important you include this in your constraint table. So we said coefficient of x here is 1 and the coefficient of y here is minus 1. If you see minus is also a coefficient which is representing value numbers, that is close to y. So we say x coefficient here is 1 and the coefficient of y here is minus 1 and it's equals to 0. Okay, so we put that in our equation. Here is 1, here is minus 1, and we just drag the formula down. Okay, and this is gonna be greater than equals to 0. Okay, perfect. Now we can bring this statement here so that it's easy for us to remember. Okay, yeah, okay, perfect. Now there's a powerful tools. Now you have make sure that you have put all the problems in the statement or in the details given to you to resolve in your Excel sheet. So having solving the problem in your Microsoft Word, touching all the variables, all the objectives, and all the constraints, and for us to see or profit, Mr. Fernandez. Okay, yeah, Mr. Fernandez. Okay, now so we have to include it here, which is our objective. What do you call it? Our changing variables is this, so we add this to, yeah, this is what we are changing. This is the value we are looking for. So here we can also click. Then the next one is subject to the constraint. So we have our constraint table. So we add all the constraint table. Now here we have a trick. If you look at the sign, you have the same sign here, less than equals to, less than equals to, less than equals to. So you can just put it in the cell references here. And the constraint references cell is also here. So you can put this because it has the same inequality. Create these 3 cells, you have it. Then it's less than equals to, check the sign very well, make sure you are not making any mistakes. Then here also you click this, and we have one more cell and row. So we have this one, which is non-negative constraint. Do not forget to do that because it's important. So we say add. Okay, we take the last one and change the sign. The sign is greater than equals to, and is, then good. So we have it. If you look at it, you have it here. and here, so you can cross-check to make sure you're right, you're not making any mistakes. Then now remember that we are solving using linear programming, so you can check down here. We have GRG, non-linear programming. We have evolutionary, but we are only looking at the simplex LG programming. So the problem we are solving. So leave that for now. In the next examples, we'll be looking at other problems that are not linear. So okay, let's click this, then everything's okay, then we say solve. Okay, now Excel has found a problem, Excel has found a solution. So the solver found a solution. All constraint and optimality condition are satisfied. So Excel has found a solution. This is great, perfect. So what do we do? Then we say click OK. Now we have it. Good. So now Excel has found a solution. The profit for Mr. Fernandez is $1,000. Okay. If he produce water-based paint of 200 and it does not produce any aluminum paints, so it will maximize his profit to 1,000. Perfect. This is great. So we can just come and write a report, a summary report statement, and says we can say Mr. Fernandez need to produce 200 water is paint and 0 aluminium paint to maximize profit of $1,000. This is great. So you can just send this report to Mr. Pedro Fernandez. Your problem is solved. You just need to produce water-based paint of 200 quantity and do not produce aluminum paint, and you will maximize your profit by 1,000. This is great. Thank you. See you in another class. Bye bye for now.